The National Electrical Code, or NEC, does not specify a number of receptacles per circuit for residential applications. However, it does provide guidance on the maximum load allowed on a 15 amps or 20 amp circuit. The NEC also states that receptacles should be installed in all habitable rooms and in all bathrooms, kitchens, hallways, and garages. Based on this information, it is common practice to use certain guidelines. For a 15 amp circuit, 1 to 2 receptacles are typically used. For a 20 amp circuit, 3 to 4 receptacles are typical. For residential applications, it is generally not necessary to consider the placement of specific appliances, such as quartz lamps, when determining the number of receptacles on a circuit. However, if there are specific concerns about the load on a particular circuit, the total wattage of the appliances that will be plugged into that circuit can be calculated and compared to the maximum load allowed. Regarding lighting circuits, the NEC does not specify a specific lighting load per square foot for residential applications. However, it does provide guidance on the maximum load allowed on a 15 amps or 20 amp circuit. It is common practice to use the following guidelines for lighting circuits. For a 15 amp circuit, 1200 volt amps of lighting is typical. For a 20 amp circuit, 1800 volt amps of lighting is typical. These guidelines include the load from both lighting and receptacles. Therefore, if the receptacle load on a circuit has already been accounted for, the lighting load should be reduced accordingly. The number of circuits required for a residential dwelling will vary depending on the size of the dwelling, the number of rooms, and the specific appliances and equipment that will be used. However, it is not uncommon for a 2,000 square foot house to require 40 or more circuits. When planning electrical circuits, it's important to understand voltage drop. Voltage drop is the decrease in voltage along a conductor due to the impedance of the conductor and the current flowing through it. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and appliances to malfunction. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by Cm, where K is the direct current constant, which represents the resistance of the conductor material, I is the current in amps, D is the one-way distance in feet, and Cm is the circular mils of the conductor. The value of K is approximately 12.9 ohms for copper and 21.2 ohms for aluminum. Circular mils is a unit of area used to measure the cross-sectional area of a conductor. You can find the circular mils for different conductor sizes in NEC tables. Several factors can affect voltage drop, including conductor size, conductor material, circuit length, and load current. Increasing the conductor size will decrease the resistance and reduce voltage drop. Using copper conductors, which have lower resistance than aluminum, will also reduce voltage drop. Shorter circuit lengths will have less voltage drop than longer circuit lengths. Higher load currents will cause more voltage drop than lower load current. There are several ways to minimize voltage drop in electrical circuits. Firstly, select the appropriate conductor size. Use NEC tables to determine the minimum conductor size required for the circuit based on the load current and the allowable voltage drop. Secondly, use copper conductors, especially for longer circuit runs or circuits with high load currents. Thirdly, minimize circuit lengths by placing electrical panels and outlets closer to the loads they serve. Fourthly, balance the load or multi-wire branch circuits to reduce the neutral current and minimize voltage drop. Multi-wire branch circuits share a common neutral conductor, and unbalanced loads can cause excessive current to flow through the neutral. Fifthly, consider using a higher voltage system, such as 240 volts, for long circuit runs or circuits with high load currents. Higher voltage systems have lower current for the same amount of power, which reduces voltage drop. Also, be aware of ambient temperature correction. The ampacity of a conductor is the maximum amount of current it can carry continuously without exceeding its temperature rating. The NEC provides ampacity tables for different conductor types and sizes, but these ampacity values are based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, the conductor's ampacity must be derated to prevent overheating. The NEC provides correction factors for different temperature ranges. For example, if the ambient temperature is 40 degrees Celsius, the ampacity of a THHN copper conductor must be multiplied by a correction factor of 0.87. This means that a 20 amps THHN copper conductor, which has an ampacity of 30 amps at 30 degrees Celsius, would have a derated ampacity of 26.1 amps at 40 degrees Celsius. It's important to apply these correction factors when selecting conductor sizes to ensure that the conductors can safely carry the load current at the operating temperature. Furthermore, understand conduit fill. Conduit fill refers to the amount of space occupied by conductors inside a conduit. The NEC limits the maximum conduit fill to prevent overheating and to make it easier to pull conductors through the conduit. The maximum allowable conduit fill depends on the type of conduit and the number of conductors. For example, for 3 or more conductors in a conduit, the maximum allowable fill is 40% of the conduit's cross-sectional area. To calculate conduit fill, you need to know the cross-sectional area of each conductor and the inside area of the conduit. The NEC provides tables with this information. You can then add up the cross-sectional areas of all the conductors and compare it to the conduit's inside area to determine the percentage fill. If the conduit fill exceeds the maximum allowable, you need to use a larger conduit or reduce the number of conductors in the conduit. It's also important to consider derating factors when calculating conduit fill, as bundling conductors together can increase their temperature and reduce their ampacity. The NEC provides derating factors for different numbers of conductors in a conduit. Also, be aware of grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which trips the circuit breaker or fuse and de-energizes the circuit. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current. The NEC requires all electrical equipment to be grounded and bonded. Grounding is typically achieved by connecting the equipment grounding conductor, or EGC, to the grounding electrode system, which consists of a ground rod, ground plate, or the grounding electrode. Bonding is typically achieved by connecting all metal parts of the electrical system together with bonding jumpers or bonding conductors. It's important to use the correct size grounding and bonding conductors, as specified in the NEC. Also, be aware of arc fault circuit interrupters, or SIs. SIs are circuit breakers that are designed to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. They occur when electricity jumps between two conductors, creating a high-temperature arc. SIs can detect arc faults and quickly trip the circuit breaker, preventing a fire. The NEC requires SIs in many areas of the home, including bedrooms, living rooms, and dining rooms. There are two types of SIs: branch feeder SIs and combination SIs. Branch feeder SIs protect against arc faults in the branch circuit wiring. Combination SIs protect against arc faults in both the branch circuit wiring and the cord connected to the receptacle. It's important to test SIs regularly to ensure that they are working properly. The NEC also specifies ground fault circuit interrupters, or GFCIs. GFCIs are devices that protect against ground faults. Ground faults occur when electricity leaks from a circuit to ground. GFCIs can detect ground faults and quickly trip the circuit breaker, preventing electric shock. The NEC requires GFCIs in many areas of the home where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor receptacles. GFCIs work by monitoring the current flowing through the hot and neutral conductors. If there is a difference of more than 5 mA between the two currents, the GFCI will trip the circuit breaker. It's important to test GFCIs regularly to ensure that they are working properly. When wiring receptacles, use the correct wiring methods. The NEC specifies different wiring methods for different applications. For example, non-metallic sheath cable, or NM cable, is commonly used for residential wiring. NM cable consists of 2 or more insulated conductors enclosed in a non-metallic sheath. It's important to use the correct size NM cable for the circuit, as specified in the NEC. Another common wiring method is electrical metallic tubing, or EMT. EMT is a thin-walled steel conduit that is used to protect conductors. EMT is typically used in commercial and industrial applications. It's important to use the correct fittings and connectors for EMT to ensure a proper ground connection. When wiring lighting fixtures, it's important to follow the manufacturer's instructions. Lighting fixtures typically come with wiring diagrams that show how to connect the conductors. It's important to use the correct size conductors for the lighting fixture, as specified in the NEC. Also, be aware of the lighting fixture's wattage rating. Do not exceed the wattage rating of the lighting fixture, as this could cause a fire. The NEC also provides requirements for the installation of recessed lighting fixtures. Recessed lighting fixtures can get very hot, so it's important to install them properly to prevent a fire. When working with electrical circuits, always turn off the power at the circuit breaker before working on any wiring. Use a voltage tester to verify that the power is off. Wear safety glasses and gloves to protect yourself from electrical shock. If you are not comfortable working with electrical circuits, hire a qualified electrician. They have the knowledge and experience to safely and properly install electrical wiring. Electrical work can be dangerous, so it's important to take the necessary precautions. The NEC is updated every 3 years, so it's important to stay up to date on the latest changes. The NEC is a complex document, but it's essential for ensuring electrical safety. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. There are also many online resources available that can help you understand the NEC. When planning electrical circuits, consider future needs. It's always a good idea to add extra circuits to accommodate future electrical loads. For example, if you are planning to install a new appliance, such as a dishwasher or a washing machine, add a dedicated circuit for that appliance. This will prevent overloading existing circuits and ensure that the appliance has enough power. Also, consider adding extra receptacles in areas where you anticipate needing them, such as living rooms and bedrooms. It's much easier to add receptacles during the initial wiring than it is to add them later. When selecting electrical equipment, choose high-quality products from reputable manufacturers. High-quality electrical equipment is more likely to be safe and reliable. Look for products that are UL listed or have other safety certifications. UL listing means that the product has been tested and certified by underwriters' laboratories to meet safety standards. Avoid using cheap or substandard electrical equipment, as this could be a fire hazard. Finally, remember that electrical work is not a do-it-yourself project for everyone. If you are not comfortable working with electricity, hire a qualified electrician. A qualified electrician will have the knowledge and experience to safely and properly install electrical wiring. They can also help you plan your electrical circuits and select the right equipment. Hiring an electrician may cost more upfront, but it can save you money and prevent potential hazards in the long run. When determining the number of circuits, also consider dedicated circuits. The NEC requires dedicated circuits for certain appliances, such as refrigerators, freezers, and electric ranges. A dedicated circuit is a circuit that serves only one appliance. This prevents overloading the circuit and ensures that the appliance has enough power. It's important to follow the NEC requirements for dedicated circuits to ensure electrical safety. When running conductors, protect them from physical damage. The NEC requires conductors to be protected from physical damage by using conduit, raceway, or other approved means. This prevents the conductors from being cut, crushed, or otherwise damaged, which could cause a short circuit or a fire. When installing conduit or raceway, be sure to use the correct fittings and connectors. Also, be aware of the minimum bending radius for conductors. Bending conductors too sharply can damage the insulation and cause a short circuit. The NEC specifies the minimum bending radius for different conductor sizes and types. When terminating conductors, make sure the connections are tight and secure. Loose connections can cause overheating and fires. Use the correct tools and techniques for terminating conductors. For example, use a torque wrench to tighten screws to the proper torque. Also, use wire connectors that are appropriate for the size and type of conductors. Avoid using substandard or damaged wire connectors. When labeling electrical panels, clearly identify each circuit breaker. This will make it easier to turn off the power to specific circuits when working on electrical wiring. Use the circuit directory to list the circuits served by each circuit breaker. The circuit directory should be located inside the electrical panel door. It's also a good idea to label the receptacles and switches in each room. This will make it easier to identify which circuit breaker controls which receptacle or switch. When inspecting electrical wiring, look for signs of damage or deterioration. This includes cracked or frayed insulation, loose connections, and corroded terminals. If you find any damage, repair it immediately. Ignoring electrical damage can lead to serious problems, such as fires or electric shocks. If you are not comfortable inspecting electrical wiring, hire a qualified electrician. They can identify potential problems and recommend the appropriate repairs. Be sure to properly size the service entrance conductors and the main breaker. The service entrance conductors are the conductors that bring power from the utility company to the electrical panel. The main breaker is the circuit breaker that protects the entire electrical system. The size of the service entrance conductors and the main breaker depends on the size of the house and the electrical load. The NEC provides tables that can be used to determine the correct size service entrance conductors and main breaker. Using undersized service entrance conductors or a main breaker can cause the electrical system to overheat and fail. This can lead to power outages and potentially dangerous situations. It's important to consult with a qualified electrician to ensure that the service entrance conductors and main breaker are properly sized. The National Electrical Code provides minimum safety standards. Remember to consult local amendments for deviations.